Professor Rad here, and today we're going to talk about conditional probability. So let's start out by defining that. A conditional probability is found when you're looking for the probability of y, knowing that x has already occurred. Here's the notation that we're going to use. And the way that we'll say that notation is the probability of y given x. So we have the probability of y, this vertical line means given x. Now, this is really very mathy of me to write it out this way. So let's think about an example. So I'll put one in here for us to think about. So consider the following three situations. Let's say I look at a room full of females, and I want to know what's the probability that somebody in that room is 6 feet tall. So in that situation, I am looking out of females, and I'm curious about which of those are 6 feet tall. So that's how I would write that in my conditional notation. What's the probability that somebody is 6 feet tall if I already know that that person is female? And then we can compare that. Let's say instead of looking at a room of females, I'm looking at a room of males. What would be the probability that someone is 6 feet tall if I'm looking in a room full of males? So these two probabilities are likely to be different because men generally tend to be taller than women. So this is a situation where conditional probabilities make a difference if you know a condition or not. And then also we could just have sort of the straightforward probability that somebody is 6 feet tall. So in this situation, we would be looking at everybody. So we would be looking at males and females together. So all three of these numbers are probably going to be different because we're looking out of different groups. So let's go ahead and look at how we can find conditional probabilities when we're using a two-way table. So in this example, it's based off of a report from 2014 done by Excellus Blue Cross Blue Shield. And basically what they found was that if upstate New York was its own state, it would have the 17th highest smoking rate in the United States, and everywhere else in New York State would have the third lowest rate. So in other words, folks who live upstate tend to smoke much more heavily, more often than those who smoke in the rest of the state. So the results of this study are compiled in this two-way table, and you can see that we're looking out of just upstate New York as our total. So this is the two-way table we're going to use. We've got different regions from upstate, and then we've got smokers and non-smokers. And as we did before when we did a two-way table example, I've got little copies of these here that we can use to help us track our work, right? All right, so for this first one, let's do that first so we can get everything on the same line. And this one says, determine the probability that I find a smoker, so I find somebody who smokes, if I only look at those who live in the Utica-Rome North Country region. So when I go to find a conditional probability, I'm going to take this given condition, so the one on the right here, and that's the only part of the table that I should be looking at because I know that that thing has already happened. So I am only going to look out of the Utica, Rome, and North Country column, and I ignore everything else. So this is the only place where I look. Now, based on this, I want to figure out how many people smoke out of how many people are total in that region. So for smoker, there were 14, and for total, there was 76. So this probability is going to be 14 out of 76. So the way I might diagram that over here, since this was region 3, numbered above, is I'm going to indicate to myself I only looked in this column. And then we had the smokers out of the total. So these are the two numbers that we used. Now for this problem, they want us to find the answer to the nearest thousandth. I'm going to put my squiggly equals here so I know that I'm rounding. And 14 divided by 76 to the nearest thousandth is 0.184. All right, let's go ahead and look at this next example. Now, unfortunately, can't really see too much on screen at once. So once we finish an example, I'm going to get rid of it just so we can see the next one. And let's work through part B. So part B says, now, what's the probability that I live in Utica, Rome, North Country if you know that I am a smoker? So in this case, instead of being given the notation for conditional probability, we're given like the actual phrase, right? So now we know that this person is a smoker. So instead of looking in a room full of people who live here, we're starting out by looking in a room full of smokers. So the condition that we know this time is not a column, but it's this row. So now, instead of only looking at a particular column, I'm only going to look out of this row. So this is what I would box in or highlight here in my little workspace. So this is what I know. So this is the total number I'm going to use. So I'm going to use this total value. And we're curious to find the probability that this is the region I'm coming from. So in this row, the Utica, Rome, North Country was 14, and we had a total of 103. So we're looking in this particular region in which there were 14 and 103 total. So let's do an approximately equal and find the rounded value. So when rounded, this is going to be 0.136. Now this answer is different from the answer we saw before, and it should be because we're looking out of a different group of people. We're looking out of smokers and picking the people who live in Utica, Rome, North Country. Whereas in the previous problem, we were looking at Utica, Rome, North Country only. So that was only out of 76 people instead of 103. And then out of that group, how many were smokers? All right, let's do part C as well. Oh, I don't know why I did that. So for part C, it says, suppose I have a friend who lives in the Finger Lakes, and I want to know what's the probability that they are not a smoker. Goodness. So this time I know this person lives in the Finger Lakes. So this is the condition I know. I know that they're in this situation. So that means I'm only going to look out of the Finger Lakes column, since that's what I know about them. Oh, golly. Now we're looking for the probability that they are not a smoker. So this is the probability we're looking for. So this is going to tell us our numerator. So non-smokers in the Finger Lakes, there's 89 of them, and there are 108 people total, well, 108, 10,000 people total in the Finger Lakes region. So once again, I'm looking at the Finger Lakes region, which was region 2. And this time the non-smokers were going to form my numerator, and the total number of people in the Finger Lakes forms the denominator. So we have 89 non-smokers out of 108. Oops. And when I divide that out, we end up getting 0.824. So one thing that's going to be important for us as we work with conditional probabilities is a situation like this. So if I'm saying like X and Y, or if I'm saying X or Y, the order doesn't really matter because in those formulas, we're using addition, which is a commutative operation. You can change order when you're adding. But in this scenario, when we had the smokers in the Utica Rome North Country, so when we were looking out of the Utica Rome North Country, we got a different answer than when we were looking out of smokers. Okay, so we had the same two variables, but when we changed the order, we got different answers. So generally speaking, if you have the probability of X given Y or the probability of Y given X, you are not going to get the same answer. So in general, these are not the same. So this means that yes, order is going to be really important for us when we go to work with conditional probabilities. So that's why I'm always looking at the given condition first. And then once I have that, then I can start to dissect the rest of this table. So that's where we're going to conclude this video of using the two-way tables for conditional probabilities. In the next video, we will look at some conditional probability formulas. So if we don't have a two-way table, how can we use a formula to find that probability? So I'm looking forward to seeing you then. In the meantime, I hope you have a wonderful day.